Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is AMIRUL HAZIQ, and today I will I will talk about activity 1 for the experiment 2. For the activity 1, I need to construct the circuit as in figure 4.1 with the main DC supply is in off position, therefore S1, and then I need to apply it to this simulation. For the first table, there are 5 station to know whether the lamp is off or on, and therefore let's try. We run the circuit, and then for the switch S1 and SG is open, the lamp is off. For the switch S1 and SG, S1 is closed and the SG is open, the lamp is still off. But when the switch S1 and SG is closed, the lamp is on. And when we open back the SG switch, the lamp is still on. And finally, when we open both, the lamp is off. Therefore, let's go for the next table, that is table 4.2. We need to conclude the S2 also. Therefore, when the 3 switch is on the open phase, the lamp is off. But when the switch S1 is closed, the lamp is still off. And when we close the switch S1 and SG, but the S2 is open, the lamp is still on. And then when we close the switch S1, the switch SG is open and the switch S2 is closed, the lamp is still on. Therefore, when we open both S2 and SG but we close the S1 switch, the lamp is off. That's all from me. Thank you.
So this the circuit for activity 2. Okay, we can observe the virtual LAN. When the switch one close, the virtual LAN will not light up. This because the twister can conduct a current only in one direction. But when we close both switch, the virtual LAN will turn on. Okay, so this the result for IA and VAK. Okay, but how to determine the holding current, or we can call the I hash. Okay, to determine the holding current, the variable resistor need to set up to 5%, and we can see the virtual LAN will turn off. Okay, so for the result, holding current is 21.733 milliampere. So that's all. Thank you.
Hi, Assalamualaikum. My name is Aiman Fatina binti KAMAL. My matrix number is DE20094, and I will present simulation for activity 3. Okay. So firstly, we just construct this circuit just like the lab sheet. Okay. So for the first simulation, we need to know the value, current value, and voltage here when it is minimum. Okay, so we run it. Okay, here we see minimum, the light is on, so we want to know the value. Okay, both are in DC form. Okay, so the current is somewhere 230 milliamps, and then the voltage is 3.3 volts. Okay, and then when we see the waveform, the green one is the waveform for here, and then the purple one is at the AC source. Okay, so when we shift up a bit, the green waveform, we can see it actually like this, positive, and when it's negative, it will be 0, like this. Okay, the AC form, just like normal AC form. Okay, and then the second thing we want to simulate is when it is medium. Okay, mid. Okay, so we have to pull it until, okay, so we have to, okay, when it's 55, it's the lamp will be shut off, and then 50. So we will only take this 45. So it is the mid one. Okay, so so we want to know the value over there. So we just simulate it, and we will get around 131 milliamp, and then the voltage is around 1.9 volts. Okay, and then when we see the waveform, we can know that the green waveform is a bit smaller, which is actually here is the alpha. Okay, the alpha. So when we go down a bit, so we can see this. Okay, so the final simulation is when it is maximum, which is 100%. Okay, here's shut off. Okay, we simulate again. We want to know the value there. So actually the value is almost to 0. Okay, so we got here like 11 nanoamps, and then here is 158 nanovolts. Okay, so as you can see, actually the range is already straightened up. Okay, so I will show you the calculation to get the range of alpha. So here is how the calculation how to get the alpha range. Okay, this is the formula. Inverse cos V of DC times 2 pi over Z Vs or V in. V in is the amplitude, and then minus 1. Okay, we just substitute the value here as we got from the simulation. So when we substitute it here, we get 77.2, and then the medium one, the mid one, is 107.3, and then here max we get 180, is equivalent to 0. Okay, so to find the range for this case, actually mid minus min. Okay, because the max is 0, so we got like 30.1 degrees. So the range of alpha for this activity 3 is 30.1 degree. Okay, that's all for me. Thank you.